Hello, my name is Henry Jerez, and I am a Senior Program Manager in Windows Azure. It is my pleasure to talk to you about all the work we have done to enable Linux workloads to run on top of our platform. As you might have heard, the new virtual machines functionality allows you to run multiple operating systems on top of Windows Azure. But we didn't just want to enable Linux workloads. We wanted to provide them with a great home on the cloud. We understand we couldn't do this alone, so we have partnered up with distribution providers and important members of the community to build a first-class experience together. We set out to build an experience that was easy to use and understand, flexible to customize, and open for you to extend. All these partners have done a lot of work to create images that are now being offered through our platform. These images have been tested, optimized, and are fully endorsed by our partners to run on top of Windows Azure. The partners stand behind the images and will in fact sell support for them once preview ends. Let's have a look at how the experience panned out. We start at the new portal. We go to the virtual machine. Inside of it, the gallery. Select platform images. These are all the images provided by our partners. Let's select a CentOS one. We will provide a name for this virtual machine, a username, a password that meets the security standards for complexity, let's select a size. Extra small shall do. I could also upload an SSH key, but let's do it later. Now let's choose a DNS name. It must be unique, but the platform will allow you to verify it is. This will take some minutes, but once the provisioning is done, we will let you know. Once a VM has been provisioned, we can go and look at the details for that particular VM. Here we can see the SSH connection string. Let's go ahead and get a terminal. Inside of that terminal, let's SSH into that machine. Let's provide now with a password when challenged. Let's provide a password. And we're in. Just the requisite ls command now. And that's it. Our first Linux virtual machine on top of Windows Azure. As we mentioned, we wanted to make this flexible. So several of our partners have created tools that allow you to create your own images or customize images that have already been prepared. In this case, SUSE Studio will allow you to create images for OpenSUSE and SUSE. Let's have a look at this experience. When you go to susestudio.com, you can choose to log in with one of the multiple account types that they support. Once you have logged in, you can choose between an OpenSUSE or a SUSE Enterprise image. Let's do an OpenSUSE one. It has to be a 64-bit to run on top of Windows Azure. Let's choose a name. Let's create the appliance. Once it has been created, I can start customizing it. I can choose the software that will run inside of it. In this case, I see we have Apache. Why don't we add PHP so that we can support that functionality? Let's look for the package. There it is. Let's add it into our image. Okay, so now I can use PHP when I provision VMs with this. We can modify the configuration from general things like setting up the firewall to more advanced things like actually editing the scripts that are run. When we're ready, we can build this image. Here you can build an Azure image just by pushing build. The build process will take some time, but the progress will be reported right here. Since this will take some time, let's go ahead and look at an image that has already been built. Once the image is built, you can upload it to your personal image repository and create new VM instances directly from it. SUSE Studio has created a very interesting tool, but several other partners also allow you to customize and manage images that are already in the platform. Such an example is Opscode with their product Chef. Here is their server. A hosted Chef server can manage multiple VMs. In this case, it is doing it for the account Azure test. Let's go ahead and look at the terminal. Here we have Knife, which is the client for Chef. Knife has been now extended to support Azure. Here we are running Knife Azure server list, which will give me the list of all the different servers that I have for this account. These are both servers that are managed by the hosted Chef server and those that are not. Now we can actually go and issue Knife Azure server create, and that will provision a new server for me. Knife will wait till the VM has been provisioned and then connect to it. Once it has established connection, it will start by installing all of the packages that are required. Once the installation has completed successfully, the new machine will try to register with the hosted Chef server. Once the registration is complete, we can actually issue the Knife server list command again, and we can see that that new VM has been created, role 106F. Let's go ahead and verify that it's here as well. Let's refresh this window, and here we go, role 106F. From this point on, you can use any of the cookbooks and recipes that you use on-premise on the cloud as well to provision software on top of that VM using hosted Chef. Another example of a partner that provides functionality, it's Juju. Juju will allow you to use any of the current charms that have been created for different cloud platforms and on premises to provision new VMs on top of Azure as well as complete stacks. You can also use other types of partners. In the case of Scale Extreme and RightScale, you can now in fact provision and monitor several machines. Let's have a look at Scale Extreme. The Scale Extreme experience starts by managing both Linux and Windows systems on top of Azure. Let's go to the library. There are templates that you can leverage. Let's start with an Azure template and launch it. Once we have launched the template, we have the option to customize it. Let's edit this one. We will select CentOS, select a name for our machines, and in fact, I want 2 machines, so let's select 2 machines. The size I can set. I can also provide a private key so that we can connect and monitor it. Let's go and select a PFX file here, provide a password, and upload it. We can then just continue and see what else this particular template does. This template actually installs the full LAMP stack and configures the firewall. I will launch the template right now. Once the template has been launched, it's part of operations, so I can see what templates are being executed. There's a template, let's look at it. As you can see, there are several operations that will be performed. It starts by creating the machines, and you can see them showing up there on the right hand side. Once the machines have been provisioned, the LAMP will be installed in each of them. And once the different components are there, we have to configure them, set up the firewall, as well as any other IP rules that we might need to enable full access to these VMs. Once the machines has been fully created, we can go ahead and manage them. So we go to the Manage tab. Inside of the servers, we can now see that for Linux, there's two new VMs. Inside of these VMs, I can actually use shell directly from within the browser. I'm gonna go and SSH into that machine. Here we go, we're issuing an LS. As you can see, we have complete access. And in fact, I'm gonna create a new file. Let's call it Azure test. Inside of this file, I'm gonna write a clever message. This is a test file. Once I have created this file, I'm going to leverage their platform to do something really interesting. I'm going to use their file explorer, which is exploring the file system on that virtual machine directly from the web. I will choose the file that I just created and select to copy it. I will copy it to a Windows machine. Let me provide a path. And the copy starts. And it's done. At this point, I'm going to go to the Windows machine. And they also have access to the command line. So here I'm in the command line of that machine, and I'm going to go to C. If everything succeeded, I should be able to see that file here. And it is right here. Let's in fact issue a more command against that file. As you can see, full integration and managing virtual machines on top of Azure. We can do more things. We can even go and look at a machine that has been running for a longer time and issue the monitoring command. Inside of this, they will have different metrics and monitoring different components of that machine, from the disk and memory usage all the way to the CPU load. This is true for Windows as well. We can also check and monitor Windows. The same level of detail is available. There's more functionality. We can actually go and manage the patches for this Windows machine. There's 9 patches that are missing. The same is true for Linux. Let's go to one of our new VMs. As you can see, there's 15 updates available. We can see the details. We can choose to install any and all of them. As you can see, it's flexible, but we wanted to make it open. So in order to make it open, we understood that you would want to bring your own Linux. To do this, some ingredients are actually needed, and they will be different depending on where you start. Linux always relies on the virtual machine's functionality. Nevertheless, the type of distribution that you choose will determine what is required. If you start with SUSE or Ubuntu, these distributions have already included all of the virtualization drivers as part of their mainline distributions. So you will only need to add SSH keys and use Windows Azure Linux Agent, which I'll explain in more detail later on. If you go with CentOS, nevertheless, the drivers are not there by default, so you would have to add them. Let's have a look at how these components play together. When you created your first virtual machine, you provided a hostname, a username, and a password. That information can be provided through the portal or the Service Management API. We will capture it inside of an answer file. That answer file will be provided to the VM when we're provisioning it. As part of this process, you have selected between a stock image or a personal image that you might have uploaded. Since you have selected a stock image, the platform will copy that into your personal storage account. That new OS disk will already include the drivers and the agent as they were present in the original image. These disks are protected by your own account password. We will then choose a hypervisor and provision a VM inside of it. Attach the local hard drive to that VM so that it's exposed, but we will also attach the OS disk and the data disk, which are the ones that will be used to boot the VM. The Linux agent will be present from the beginning, and when the VM boots, it will consume this ISO disk to provide provisioning operations on top of the platform. Let us now look at this agent in a little bit more detail. As you observed, during the Service Management API portion, you have provided information that will be made available to the VM through an ISO. When a VM is selected inside of a hypervisor, this ISO is made available. The fact that this VM includes the agent allows it to run during provisioning. This agent will go ahead and consume the information for the provisioning and set things like the hostname, create usernames and passwords. In addition, it will assist to retrieve the SSH keys by establishing a secure channel with the platform. Once the provisioning has ended, this agent will remain behind because it needs to assist the platform in important operations such as the hostname change. The agent is responsible for informing the internal DNS component of a hostname change and ensuring that you can still resolve these names. The agent also helps with stability. When a hypervisor fails or a node malfunctions, we will service heal your machine and move you to a different hypervisor or node, even potentially a new data center. The agent will assist to ensure stability by making sure that the new MAC address does not result in the network device name changing. This is one of the reasons why it is so important that this agent is open sourced. Since we have released it under the Apache 2 license, you are welcome to modify it and enhance it so that any potential kernel tweaks that might interfere with the platform operation or be adversely affected by them can be addressed directly by this agent. You are of course welcome to extend its functionality as well so that it provides more operations for you. Let us now look at how the Bring Your Own Linux image would work. We start with a terminal window. We assume that you already have a VHD that you have either created locally or downloaded from one of our partners to customize. We will be using the Azure command line tools. These tools that are released under open source Apache 2 license will allow us to interface with the Service Management API. Let's issue an Azure VM image create command, where we're providing a location for deployment as well as a type of OS and the name for this image. Well, let's call it my Ubuntu. When we start the process to upload this image, the API is contacted to retrieve all the information needed to store the image inside of your personal image repository. This process will take some time. So while this is happening, let me start preparing to show you the ability to create images also on the cloud. Let's go ahead and go back to our original Linux VM. This is the VM we just created. Inside of it, let's assume that I'd like to customize it and install an Apache server, so that from now on every VM that I provision will have Apache installed by default. Here you go, we're downloading all of the components and Apache is installed. Now I will issue a command with the Windows Azure Linux agent that is called deprovision. This command can also include the user parameter, in which case we will deprovision the image and also delete all user information so that it's suitable for other people's consumption. I would like to proceed, and this operation has given me a VM that is ready to be captured. Let's go back and see that the upload is almost done. When the upload has concluded, we can also use the Azure command line tools to obtain the list. Azure VM image list should be able to provide us the list of images. And as we can see, the My Ubuntu image is there. Let's go now to the portal. Inside of the portal, I can select now to create a new virtual machine. In that machine, I will select my images, and there it is, my Ubuntu. Once again, I will provide a name, username, password, the size, and this time around I will be uploading an SSH key. I will select a key that is already in my system and continue. I will choose a name and the provisioning starts. Once the image has been fully provisioned, I will be able to connect to it. So let's get some details. Here's the SSH connection string. Inside of the terminal, I can now connect to this machine. And here we go, the machine was created. Let's go back. Remember I told you we can create an image from our running VM? Let's shut down this VM first. This is the VM that we had already prepared. Once we have shut it down, we can go ahead and select it again and issue capture. The first step is to choose a clever name. Let me see, how about new Linux test? That's right, I put Apache with Apache. I have deprovisioned this machine, so I can just check this in, and the process starts. During this process, the VM will be transformed into an image. It'll take a little, and when it's successfully created as an image, I can now go back into the virtual machine tab, select from gallery, my images, and there's my new image. That's how you create images in the cloud. Now, let's talk about our interest in the community. We understand that to be a successful community member, we must contribute. That is why we are open sourcing the LIS drivers, the Linux agent, but not stopping there. We understand many partners will want to build their own tools, so we have fully documented all the APIs, provided these native tools as well as client libraries so that you can leverage all the Azure resources from within Linux and Mac OS X machines as well as Windows. Hopefully this will be enough to get you started. We look forward to your feedback and the opportunity to build a better home for Linux in the cloud together.